Hello, this is Himanshani from IIPS, DAVV University Indore, and here I am presenting NAD internal 1 solutions. The question 2 is, write an algorithm to evaluate polynomial px equals to a0 plus x into a1 plus x into a2 plus and so on plus x into a n minus 2 plus x into a n minus 1 plus x into a n. Now our solution is, the algorithm for this polynomial is written as, first of all we read x and n, and then we start the loop for I is equals to 0 to n in steps of 1, like we increment I by 1 in every iteration, and then we read a of I. Then we end this for. Now we substitute the value of an into p, and then again we initialize a for loop with I is initialized to n up to 1 in steps of -1. Now this is a backward loop from n to 1. We are putting the value of a I minus 1 plus xp into p. Now here the for loop ends, and then we write the value of p, and then we stop our algorithm. Now the second part of the question is, obtain the recurrence relation for dividing a polynomial px and write algorithm for corresponding polynomial division by x minus r. Here is our solution. When we divide a polynomial of the form an x to the power n plus an minus 1 x to the power n minus 1 plus and so on up to a1x plus a0 by x minus r, we will be getting the quotient as an x to the power n minus 1 plus an minus 1 plus ran into x to the power n minus 2 plus a n minus 2 plus r into a n minus 1 plus r into a n into x to the power n minus 3 and so on. We call this quotient as bn minus 1 x to the power n minus 1 plus bn minus 2 x to the power n minus 2 plus and so on up to b0, where bn minus 1 is equals to an and bn minus 2 is equals to a n minus 1 plus ran. Here also we can write this as a n minus 1 plus r into bn minus 1 and bn minus 3 as a n minus 2 plus r into a n minus 1 plus r into a n, which can also be written as a n minus 2 plus r into bn minus 2. Therefore, in general we can write this as bn minus I plus 1 is equals to a n minus I plus r into b n minus I. Now the algorithm for this division is, we start with the for loop in which I is initialized to 0 for I equals to 0 to n. In steps of 1 we read the values of ai, then we end this for loop, and then we place the value of an into bn minus 1. Then again we starts a for loop with I initialized to 1 up to n minus 1. In steps of 1 we put the values of an minus I plus r bn minus I into bn minus I plus 1, and then we again end this for loop, and then we start our third for loop with I initialized to 0 up to n minus 1. In steps of 1 we write bi, and then we again end this for loop, and this is the end of our algorithm. That's all. Thank you.